Alright, there we go. I think this is working now. Yeah, okay. I think we're good. I mean, I'll double check and just be certain. Yeah, okay, we're good. So, part 2, I guess. I confess I have done a little bit since the last stream. Bam, that's all I've done. Is if anybody cares. Um, but yeah, I need to do. Okay, I need a few things here. Bring this over. Flashbang. I'm sorry. We'll bring that over. All right, this is the important doc though. This is a great doc, but this is the important one as of right now. So we are doing indexed, indirect. Shoot, there we go. Type beat. Right. Uh, yeah. So I genuinely have not looked at these at all. I don't know what they do. I mean, I have a rough estimation of what they do. Bear with me here. May or may not reference this code base occasionally. This is a old NES emulator I wrote that is in many ways already far worse than what I'm doing now, because it was instruction stepped, uh, in many ways rushed and just bad. I mean, you can see the massive if context per chain. It's like, I don't know, this I admit is terrible. And I wrote this barely knowing what I was doing in undergrad, so but yeah, this thing is, there's a bug in my room. Oh man, whatever. So we're doing this. We're doing indexed, indirect, and then oh, this bug's gonna drive me insane. Uh, Indirect indexed. So indirect, bro, moment, 0 page x. Right. So 0 page with an x offset. You take that, you use that to reference the thing. Okay, so we fetch pointer. So, yeah, in many ways this is going to be tricky. So, first things first, I think I'm going to need a separate like member. I don't even know if I should be calling it members for rust struct, but struct member for this pointer thing. New microops for each of them. And then thankfully this looks pretty familiar. Read from effective address. Then we have read from effective address, write value back to it and do the operation, and then write new value to effective address, and then just plain write the effective address. And then each of these is fetch the thing, do the offset, read low, read high. Then we have fetch the thing, read, do the offset, low, high, fetch the thing, do the offset, low, high. So thankfully this one seems a bit more straightforward than what I was doing in the last one. I am having water as I do this, and for some reason water makes me burp more than soda. So I mean, if that triggers you for some reason, you can I don't know, deal with it. But yeah, so first things first. Moss. I need to modify this struct. So we need. It's like this works. This is cool and stuff. And then I need like a pub. Let's see. Do I want big register? Yeah, big register, by the way. And like maybe there's. I'm aware that you can do val.2le bytes or something. And I don't need all these like wrapper methods around a stupid frickin' this. So it's like I'm not that naive. My problem with it is I see LE and think it supports little endian only. So I mean, I could be wrong, but I did this because I don't want to take chances in that regard. I want this to be a pretty well supported emulator, similar to our previous one. So, I mean, I posted some stuff about this previously, but we ended up going all the way and doing a libretro port, which basically gives it compatibility with RetroArch. So, I mean, if you can compile it for some platform that has RetroArch on it, and get a shared object or whatever, you know, whatever the equivalent is on Windows, it's a DLL. On Mac, it's like a dilib, or maybe that's iOS, I don't know, but yeah, I mean, I've played this emulator in Steam, so, and it's a good feeling, I don't know. So, in the same light, I want very wide hardware support. So, confining myself to little endian only, even though little endian is like common. If an architecture is sane, it probably uses little endian. I don't want to take my chances. So, pointer. And pointer is going to be, okay. So, I mean, we kind of have to do this fetch, address low, fetch. I mean, if we're doing one of these at a time, I guess I might as well use big register. Because then I can use my set low, set high methods. Trust the compiler optimizations. Abstraction is not a bad thing. That is my philosophy. As long as abstraction is all it is and not obfuscation. So yeah, pointer. So next thing I'm gonna need. Yeah, honestly, all of these are probably gonna need to be. These are all probably gonna need to be like crazy things. So pointer, fetch pointer address. I see. So these come in as immediate. Okay. So I'll do ALULOP. I'll do, screw that. Actually, I want my address modes. Not. Oh man, I'm losing it today. Micro ops. So just do 4. This is indexed, indirect. I guess follow. Yeah. That was terrible. So we'll do fetch pointer low, fetch pointer high. What else? Fetch indirect. I guess index indirect low, right? That'll be this, and then shoot. High. Okay. Fetch pointer low. And then this will do index. The heck is IDR? It's a stupid name. Index indirect. Sure. so this is going to be quite simple. Let val CPU fetch. Alright, so that should handle, oh, I mean, I guess this also has to add X. I mean, this kind of sucks because, actually no, it doesn't. I think, I don't know, let me reference this. I think all this is, no, there is a ZPY. I think the ZPY is different behaviorally, maybe. No, it's not. Shoot. Is this, like, used anywhere? Okay, whatever. It doesn't matter. I'll worry about it later. And I think the effective address is always fetched from 0 page. 0 page boundary is not crossed. Or sorry, 0 page boundary crossing is not handled. So there's an edge case here. So that makes my life easy, actually. Yeah, hardware bug making my life easy. Who would have thought? And it looks like I did that here as well. You fetch the thing. Hang on. Now this is, hang on. This is confusing now. Indexed, indirect, index, indirect. I might be confusing two addressing modes. That's confusing. Index, indirect. Why does this not make sense? Okay, I honestly don't trust my old emulator. It was like kind of terrible anyway. They don't say anything about, because in the docs further up they use a Y to denote this could be X or Y. Here I see only X. So only X. X is all I'm going to implement in that sense, because like why bother? Yeah. It very deliberately says X plus 1. Okay, so I have to add X and then drop the low, or not to drop the low, drop the high thingy. So I mean this should be quite simple. I'll do CPU bus fetch, wrapping, add CPU X. Right, and that should handle. Oh, this is messing me up. No, something's not adding up. Fetch pointer index. I see. I'm misinterpreting. Okay. I'm stupid and I don't read. Forgive me. Let's rethink this through. So we fetch a single byte as an address. Right, then we increment the PC, we read from the pointer, then add X to it. Okay, sorry for the redundancy, I'm gonna have to redo some things. Sometimes it's just easier to restart from a clean slate than, oh man, did I remove this yet? Yada yada yada. Okay, fetch effective address low, fetch effective address high. Okay, so read from the address, add X to it. So we fetch the pointer, increment the PC, read from it, and that's just because it always has to either read or write, so it reads from the effective address, whatever, or not effective address, but the pointer. Add X to it. Okay, I know what I'm doing now. I am slightly brain dead. Okay, micro op. And I also need to bring back that pointer. Shoot. Okay. This is for indexed direct. And we're gonna do fetch. I'll just say fetch pointer byte. So we'll do that micro op. I mean, this one's an easy one to do. I'll do them one at a time. Micro op, fetch pointer byte. So I mean, like, this is quite simple. Let val equals CPU fetch as u8, or I mean, I guess whatever. CPU dot pointer val as u16. Right, that way you don't have to deal with the. You know, this probably doesn't even need to be u16. You could probably get away with just using an 8-bit value, but whatever. Since it's 0 page and the high bits clearly don't matter. But anyway. So we have to read and add X to it. So PTR add X. Micro op, thank you. I gotta say, Rust, whatever, I think I'm using, I don't remember what LSP I'm using. No. What LSP? Rust Analyzer is like very intelligent with its suggestions. I am not using Copilot or anything with this editor. Yeah. But it's pretty intelligent. Like, it will gravitate towards things that haven't been implemented yet. When you're filling weird match, match, I don't know what the heck to call them, match statements, if they're statements, I don't know, expressions. So I have to read from this, and I'm assuming this is just discarded, so let underscore equals CPU read, sorry, that would be bus, read byte. That was a burp. Okay, so that reads this, and then we have to add X to I guess we can do pointer dot I don't like that. Get low. And say CPU pointer. Wrapping add CPU X. Pointer. Get low. Sorry. Set low val. Right. Right, so that's a hardware bug that we now support. It's like kind of insane. I don't know if I mentioned it when I was building the last simulator when streaming, but there's like this crazy phenomenon where it's like things are almost simpler in many ways if you follow a clock cycle accurate design pattern. And that sounds like very counterintuitive at first, but with low level systems at least, I mean, I can't say for higher level, more complicated things like N64, but at least with low level, you have weird hardware bugs, or low level and like really old. So predating probably SNES. I'd say SNES and before that, anything before that. It's like so many weird hardware bugs are what make it difficult to emulate well. And if you're doing things at like a very high level, it's like why would this ever exist? It's like, this is stupid. Why would this ever exist? But when you actually look at it on a clock cycle per clock cycle basis, it makes a lot of sense why this doesn't exist. And it becomes easier to implement as a result. I don't know why it's happening. It's not just like some ridiculous requirement you have to follow. Yeah. So I mean that should handle this, and then fetch effective, fetch adder low. Yeah, see, like, this is what I mean. It has all these options, but it knows this one. It's like, that's cool. C++ couldn't. Like, I love C++, but Clang D, it doesn't do that. Or maybe it does, and I just haven't configured it to, and I'm retarded. We'll never know. Fetch effective select let val equal. Ooh. So now here's an interesting question: is boundary crossing the effective address is always fetched from 0 page? 0 page boundary crossing is not handled, but is it handled when you cross this? That's not an easy question to answer. Because they say the effective address is always fetched from 0 page. I'll assume that it doesn't matter for now. Fetch, I mean, how did my old one do it? Not that I trust it, but I'm just curious. Oh, shoot. Said, this code sucks, man. This stuff is so bad. Why did I do it this way? Is this horrendous? It's the ugliest. Gosh. Terrible. ZPX. I mean, I'm assuming ZPX is what I'm supposed to be looking at. Maybe it's this? Okay, this looks a little more reasonable. Okay. So oh my gosh. See, I don't know if the naming is so confusing, man. I don't know if this is referring to... Okay, this looks like what I want. right? What is, oh gosh, garbage in my frickin' Firefox homepage. I think this is the only thing that actually uses just plain index, like indirect addressing. Okay, yeah, I'll handle this one off, that's fine. So I guess what I am dealing with is I'm dealing with indirects. Okay, this is what I'm doing. So we read a byte, add X to it. Okay, that makes sense. I'm really starting to think. I see. Okay. Sure. So yeah, increasing it by 1 does not cross the page boundary. At least that's the assumption I made before. So I'll make that assumption again. So fetch address low from pointer. I don't know. I almost don't want to. Whatever, it's fine. So I'm just fetching the low byte. So bus read byte CPU pointer val. And then CPU adder set low val. Sure. Okay. Fetch effective address high. Effective address high. Effective address high. Effective address high. So I have to increase it and then let's see. CPU pointer get low wrapping add 1 as U16. Read byte. See, I'm stupid. Pointer. I don't know. Screw it. Pointer. I'm gonna put question marks there because I don't actually know. I mean, maybe it's so tricky, man. English is so vague. It's like the effective address is always fetched from 0 page. But when you're reading using the effective address, does that also... I might be stupid. Yeah, I might be extremely stupid. Never mind. Okay, I'm just dumb. Never mind. This is probably right. Okay. So this is fetching the high byte. CPU... What am I doing? Pointer x plus 1. Read that into high. So pointer. No, it's not pointer. This is address set high. Okay, sorry, someone walked in. This looks good. And then address. So then this, okay, so for read instructions, this will come as part of the ALU up. I know it's like not the most intuitive thing ever, but you know, for or A, or and ADC, CMP, like this will do the ALU operation. Lax is an illegal instruction, by the way. But regardless, so this is part of the opcode. Here, this is part of the opcode, and then here, this is also part of the opcode. So I don't have to do anything with that. We've all. Alright, so now if I go to impl address mode, index direct. So I can do, I mean, we know we're obviously gonna need that, right? We're also gonna need so now we have to do all this junk. So it's just like, alright, you ready for some Vim magic? Shebang. Shift it over. S. Sorry, norm. There's a more efficient way. So I do that, I do that, ALU, push, ops, A, so close. I suck. Micro op. And I'm also just, oh my gosh, I'm stupid. This is micro ops. It's late, right? And it's just push. Money, 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 money. So okay, let's do a proof of concept walkthrough here. All right, so we're decoding, and we get to this point. Okay, let's say I'm doing a update flags, right? Okay, no, this is a good one to check. So a, right? You can hit that with indexed indirect addressing. So we go. I mean this. So if you haven't noticed, I'm not treating. I mean it is a micro op, but I'm not treating it as something that exists in this list of micro ops because it's generic to every single instruction. So anyway, I handle this logic elsewhere, but we fetch the pointer address. So this is a single byte because it's 0 page and increase PC, right? So it's this. Okay. So another interruption. So fetch pointer byte. Right, fetch it and then just kind of set that. Right, we intentionally wipe the low. I probably don't need anything more than 8 bits for this. I might rewrite the logic. Yeah, what the heck. If I can get away with doing this addressing mode with 8 bits, I'll rewrite it. If not, I'll leave it. But we read the pointer, we clear the upper byte, just the lower byte. Right, so that handles this. And obviously because it's fetch, it increases the PC. Okay, fine. Then we do pointer add x. Pointer add x. Bus. Okay, so that reads this. It doesn't do anything with it. It just discards it, and it's fine. We do value add x. Okay, so we're taking the low byte, adding x, wrapping around so it remains 0 page, right, set low, yada yada yada. And then we have this clock cycle, we fetch effective address, right? So we do, uh-oh. No, my internet's good. I don't know what the deal is. Okay, fetch, so we reread from whatever this is, set the low byte, that's fine. Then we read whatever this is, set the high byte, and again, don't do page crossing. So we do this, we add 1, this overflows, it wraps up around 8 bits, U16, read it, set the high. Then we do this. So like up until this point, this is correct, this is correct, and this is correct. Yeah, I mean that should be fine. Yeah, sure, whatever. So it should be indexed indirect. It should, I mean, I would like to hope it is clock cycle accurate. It's probably pretty close. Yeah. I will probably leverage some form of single step tests before moving on to anything crazy after this. Probably even before I do interrupts, honestly. Let alone trying to actually execute ROM. It's like if I start executing a ROM, it's just gonna get hung up on some stupid polling loop because I don't have any MMIO registers yet. It's all stubbed to just a fallback array of nonsense memory. So it's not gonna do anything. It's just gonna forever loop, assuming it's even correct. Okay. Indirect address. Wow, indirect indexed. I can't read, my guy. Indirect indexed. It doesn't help that I keep reading this is indirect indexed. These words look so similar. Indirect indexed addressing. So, okay, we fetch pointer address, increment PC, fetch effective address. These look oddly, like strangely familiar. Oh gosh. Yeah, this looks like a nightmare. I see a plus here, which scares me. Okay, but it only happens with reads, so that means I'm probably gonna need another get ALU source hack. Oh! That's a problem. Adder mode, because I am doing this. I should make sure I'm not, like, botching this. Everywhere I do absolute X, I should do it the same thing for absolute Y. That's good. I mean, except for here, because this is just how it's decoded. Okay, I think we're fine, honestly. Yeah. Cooking. Okay. So how many of these can I reuse? So it's nice because these are like right next to each other. So I mean for read, I mean this is what I'm gonna have. This is gonna have to be handled by the ALU up itself. So I don't like it, but this logic is gonna have to be baked into the ALU up. Because again, this probably delays the ALU up, right? Because if you read from the wrong thing, you don't want to, for something like ORA, you don't want to mess up the contents of the accumulator if you have the wrong byte. So, kind of a, I mean, I haven't read that anywhere concretely, but I can imagine it's probably what the hardware does. Otherwise, you would lose what you have in your accumulator and corrupt the entire instruction, which would be terrible. So it's these versus everything, but can I do this? Oh, that's fancy. Thank you, Firefox. So, I mean, clock cycle 2 is the same. Clock cycle 3 is not the same. This is confusing me. Shebang, and I only want this shebang. Right, so we fetch the pointer from the address and increment the PC. We fetch the effective address low, fetch the effective address high. So again, I'm assuming this probably doesn't cross page boundaries. Oh, I see. You have to do, okay. Nah. I'm worried about this increment. Does that cross? Is that allowed to cross the page boundary? So this would be IZY. So we read the low, we read the high. Looks like I didn't worry about that beforehand. So it's probably okay. Yeah, I mean, again, this is really not code I can trust, because my old emulator was a piece of junk. Gotta start somewhere. Yeah. Fetch pointer address. Okay, so. I'm gonna commit this, because I know that this is probably correct. It's probably fine. For index, yep. I mean, I'm gonna end up reusing this, so just kind of put it somewhere general. Yeah, I mean, this was a bug fix. Glad I noticed that now. That would have been a miserable thing to look for later. Fetch pointer byte, so that fetches the low, yeah, whatever, clears the 0 page. Or the upper byte, making a 0 page. Pointer add X. Yeah, I think that's probably fine. And then we fetch the low from the pointer. And then do that. Sure, man. See, so what's like annoying is I kind of want to reuse this and this for this. No, I can't do that. Unfortunate. Whatever, it's fine. I think this is sufficient for now. Okay, so this was... I don't even want to risk typing it wrong. I don't trust myself. There. That's stupid. I want interesting mode. Alright, so once that's done... Dang, once that's done, we'll have all of these. Okay, so let's keep up with the sort of thing I've been doing. Oh shit, I'm getting pings off screen. Really grateful for whoever went through the pain and suffering to create frickin' MS Paint and JavaScript, and that sounds like agony. Yeah, so this was the indirect addressing with X. So bang bang, we have this, we have this, we have this, shoot, that, and that. Yeah, this thing is frickin' stupid. I can't. What else? This is stupid, this is stupid, these are stupid. Yeah, these are implied, so I'm gonna just do them separately. But yeah, this is what I want. This is where I want to be tonight, by the end of tonight, ideally. And then after that I can just work. I mean, these are just ridiculous. I don't know how I'm going to do branches yet. Branches are a pain. Specifically conditional branches are going to be a massive pain because I have to deal with variable length, not variable length, but variable clock cycle granularity. Yeah. Type beat. More or less. Okay. So I mean, we know one thing, that is we can reuse fetch pointer address increment PC. Fetch pointer address increment PC. That just fetches this thing. So now I ask myself the question, is it worth just doing this with this is really bugging me. I want to know if... Oh, I'm looking at the wrong one. I want to know if this handles page boundary crossing. Honestly, I might bug someone on Discord and ask that question real quick. Oh, someone's typing. Nope, they weren't typing to me. See, this is the fun thing, man. If you ever, okay, this guy might be typing to me. I mean, if I've learned anything, it's don't get your hopes up. But yeah, no, these guys look like. I mean, hey, fair enough, right? Let's see. Indirect, indexed, page addressing. Or sorry, page boundary. Page boundary. I can't type page. Alright, let's see what we have going on here. Do not add me on Discord. I will ignore you. I mean, you can probably guess what the rest of that is. Don't bother. You have to fix. Yeah, I mean, that's probably not gonna help me. Whatever. Who cares? I mean, you can always. I wonder if they talk about it in this doc. Indirect index. Shoot. ZPY? Okay, maybe they talk about it here. Indirect comma Y. Oh my gosh. Shut up. Get to the point. Here we go. Time to feel like an idiot. Right, so, I mean, store opcoding PC. Okay, store pointering PC. Store as address, sure. Then you read, okay, I see. So you read the pointer. You read the pointer plus 1. So I guess the answer is no. So I guess my old emulator actually did do it properly, which is, I mean, I guess not a surprise. It did pass rudimentary CPU tests. I mean, if anybody goes back and tries it, it's probably not going to pass anything related to memory access timing. But the basic functionality of the instructions was at least reasonable. Kinda. So did I okay, I did that much. Okay, so we fetch the pointer, we increase the PC. We fetch the effective address low. Yeah, so this means I need to do, shoot. I want to do micro ops, push, micro op, fetch, adder, fetch address low from pointer. What does this do exactly? I don't remember. Low from pointer. Yeah, see now this this sucks. I can't reuse this because this doesn't do the page boundary crossing like it should. Let me just double check again. This... I'm questioning if I should even be doing page boundary crossing here. Like, with this. That's, oh, it's so confusing. I'm doubting myself. Read from the address, add X to it. Oh yeah, here we go. Here we go. I hope this guy somehow stumbles upon this someday. I'm an idiot. Regional indicator. Alright, well, if you ever see this someday, I hope you're doing alright, bro. That's funny. Man. Uh-oh. Ugh. My Wi-Fi suffers. That's not that bad. Fetch effective address. I want to know if this suffers. I want to know if this... Where exactly does the page boundary... Where does it become a problem? There's two places. Alright, I'm peeping the old emulator again. We have low, we have... Okay, so I'm looking at this first. Yeah, so for this one, the increment does not respect the page boundary. It wraps around. And then for this one, it looks like I'm doing the same thing. That contradicts this. What to believe? I mean, it's probably this. Oh, this is doing Eeyore, okay. So I can ignore everything up until, yeah. Target equals... I mean, yeah, I'll just... Okay. So I'll do this. I'm gonna have two versions. I'm gonna have one that wraps. I'm gonna have one that doesn't wrap. So this one is gonna wrap, and this one's not gonna wrap. And they're both gonna be pretty similar in behavior. So literally, this is all like stupid. We'll do CPU pointer val is... Hold up. So I need to be reading from... Again, don't look at this. This is what we're looking at. Pointer and pointer plus one. So literally I have to do bus read byte CPU. I am an idiot. CPU pointer, val. I'm not gonna need the wrapping, but I mean, whatever. It's redundant. And this is to read, not that. This is to read the high. Okay, I can live with that. So that's already in place. Sure. And then I have to do this junk. This is going to be a pain. Read from effective address, fix high byte of effective address. Yeah, so I mean it's going to be pretty similar. So these are done. I don't have to do anything else here. Get alias source. Header mode. This is indirect indexed. Indirect indexed. I mean, I can probably do the same thing here, right? Read effective address, fix. Yeah, I mean, this is like the same. This is the same stuff. Header mode. Indirect indexed. Same exact logic. It's nice because I don't have to do anything anywhere else with any ALU operations. This is just, that takes care of it all. Right, that handles this logic. And then ALU op. I'm gonna probably have to do the same thing, right? And it's probably exactly the same. It's probably just this, right? Because all this does is it reads into the temp. Temp is what I'm using for the, you know, temp is what's used for the ALU. Like going in, it looks at temp. Read byte from effective address, fix high byte. I'm looking at read, I'm stupid. Okay, so I'm looking at this now. This is handled. This is handled. So then there's read high byte. Okay, this is where things get screwy. This is read modify right. Let's start with this. Yeah, so this will be handled. This will be handled by. Okay, so if we're doing just plain write instructions, this will be handled by doing header mode. My LSP doesn't work inside of macros. It's very frustrating. I want this one. It's like, I wish it would just let me frickin'. I don't know. I'm very, like, for language formatters. I think they're a very good thing if you have, like, any standards for code quality. Until they do stupid shit like this. It just makes me so angry. Forgive the language. Read from yeah, it's the same freaking thing. So this is handled, and then this is read modify write, so I can ignore these bottom three, and then I just kind of have to do that, which is like the same thing. Adder mode. I mean, basically this. I'm not gonna risk typing it wrong. Oh, come on, man. There's gotta be a better way to... can I just say, like... let goofy equals... what are you doing? Okay, I mean, I guess I can't really be surprised. Whatever. I'll leave it for now, even though it's absolutely horrendous. That's funny. Okay, bear with me here. Bear with me here. I mean, you can probably guess what I'm doing. What? Yeah, but it's like, you know, I'm genuinely trying to learn Rust, so I've been very minimal with my LLM usage. It's like, if anything, I'm trying to get it to, you know, I will ask it things about syntax, sugar. Okay, see, like, this is the kind of stuff I'm talking about. It's like, yes, I remember reading about, man, I just need to remember to use stuff like this. It's like another perfect example is, where am I? Moz. It's like this syntax, man. It's great. And I remember, it's like, man, let me pull up the doc I used. I used like a book. It's like amazing site. Amazing site. It's like a nice pandoc of, you know. But the problem is I go through it, it's a bunch of stuff, and I forget it. And then, you know, I see this thing, and it's like a reminder. Okay, yeah, that exists. So yeah, I mean, I don't hate that much. So I can just like const fix. I can take this. Oh my. Does it not like that? It still doesn't like that. Oh, duh. It still doesn't like that. Boy. There we go. And then I can replace this with if fix that contains adder mode. Why do you hate me? Cannot compare. Alright, no, I'm not doing all that. I'm not doing all that, bro. Screw it. This is fine, I don't care if it's ugly. I'm going down a rabbit hole I have no business going down. This is fine. Gets the job done. Someone is going to make fun of me for going through all that. But whatever. This looks fire. so let's walk through a little proof of concept here. Brain damage. So we'll do indirect addressing. Let's see. Right. Ooh, I'm struggling. Thinking, what am I doing? We start at this level. Okay, so obviously we do this, right? We're doing indirect index, right? So we fetch the pointer low byte. So let's assume we're doing an array. Okay, we're doing an array. I like that opcode. Or a of date flags, yada yada yada, whatever. There we go. Okay, so we fetch the byte. Right, all that's doing is it's gonna set the low in the pointer. And then we do this. Fetch effective address low. Right, so that should do this. Right, so this takes that pointer, we read the low, and then we fetch effective address high, right? And we're doing this stuff. Right, yeah, so this does not say anything about this not liking the page boundary, if it exists. So we let the page boundary do its thing, we don't really care. Right, fetch effective address, add a y to low byte of effective address. Add y to low byte of effective address. Add y to low byte of effective address. So fetch from whatever. I mean +1, right? Yep. And then just set the low byte, fine. And then read from effective. Oh, I'm not adding frickin' y. Shoot. That is like kind of a very critical. Okay. That's okay. That eases a lot of confusion. I'm gonna nuke the. I gotta stop saying that, bro. I'm gonna delete this for now, and then I'm gonna rewrite it. All right, we'll come back to here, bruh. This is my marker. I mean, I could just use Vim marks. I'm gonna delete this so that I can prove that I use Vim marks, and I'm not just a complete retard. All right. So what am I doing? Wrap. I don't like this wrap anymore. It's always gonna wrap. I mean, it's a right. So basically, what I'll do instead is I'll add y. Hang on. Fetch effective high. No, it's still bugging me. No, it's still bugging me. I mean, I needed to re-implement it anyway. Add y. Sure. That's reasonable enough. Well, I had a plugin that used to get rid of these when you moved. So it's like, okay, I did this, this character, do that character to highlight and go to the next, and it would. You do that and it would unhighlight. I need to reinstall that plugin. It was a really good plugin. Anyway, add y. So now, what are we doing? I'm taking I'm taking the effective address, not the effective address, but I'm taking that pointer. So I'm thinking we'll do that. Do CPU pointer val. Something. And then, okay, I see what needs to go on here. I need to set the fix. I need to set the fix and then just set the low byte. Okay, similar to how I did before. Okay. This makes sense. So set. We let the val. We read from this pointer. That's fine. And then I need to do not that stupid editor. Okay. So I mean, we do this. This is fine. And then CPU.adder true or adder fixed equals CPU adder val wrapping add CPU y as U16 as U10. That is definitely a thing. That would make lots of sense for a. No, it wouldn't. Adder fixed. Right, so that sets that to something sane. And then set low fixed shoot. So that sets that. Okay. So we have this guy pointer. We increment 1, right? Because we're reading from this guy. We take that byte, we fetch it into the high byte of the effective address, right? So we read this guy, bang. Honestly, I'm gonna do. Oh, what are you doing? Sure. Okay. So this happens in the same thing, right? So we fetch that into the high, then we need to add y to the low byte. Right, so I'm doing it for the whole thing because I use this to determine if the address is screwed up. Right, so do that. This is where it's going to read from, is the CPU adder, not adder fixed. So CPU adder, and then we just set the low to whatever the heck. After, yeah, that's fine. Works for me, man. Add y to low byte of effective address. Yep, and then this is handled. Okay, so going back. Hey, notice what I did there. I used a mark. Right. So what did I? Yeah, I have add y. I think this might be cooking. Yeah, let's go through it again. Sorry if I'm like doing a lot of jumping around here and not a lot of talking for random periods. I'm kind of monitoring Discord on my other monitor. Oh man, am I gonna have the settings? Yeah, just a slight flex. 5070 Ti. it's not even what I wanted to show. Bam, that's what I wanted to show. So yeah, I have Discord on that right monitor. Takes up the whole thing. Kind of thinking about replacing it for just, like, all three of them for just a single ultra wide. But I don't know. It's like I worked somewhere that let me use an ultra wide, and I just had freaking like 4 Vim splits. It was the best thing ever. It was so nice. It's like I didn't need 3 monitors. Anyway, so we fetch the pointer, increase the PC, right? That's what this does. Yep. Okay. Right, and then we're gonna do fetch the address low from the pointer, right? So this is gonna fetch into the effective address. We fetch that low byte. Then we're gonna do this guy, right? So we fetch into the high from the pointer plus 1, and then we add y to the low byte. Okay, so we increase, read it. Again, ignore the page boundary, it doesn't seem to be a problem. So, and then we take this, yep, we add the Y register, does some stuff, who cares, CPU, add or set low. We only set the low byte because here, this thing might get screwed up. Right, so now, if there's no, there's no page boundary crossed, then this happens, we read the byte, and these will match, right? The fixed will match this because the high byte is the same, right? So then we will return false here. This will not happen. We will update A with corresponding thing. By the way, in update A, I do some stuff with some flags, so this is not incomplete. Do not bug me in the comments. I update my flags. Shut up. Okay, so I think that looks fine. And if it does cross the page boundary, these will not be equal. So this will return false, and then it'll go through that whole sort of step where it basically retries this instruction after fixing the thing. That's what this is for. Cool. The true means we retry. Easy money. So now let's think about write instructions. Okay, so we know this is right, this is right. I hope this is right. So now we're looking at ALU op this junk. Right, so this is the one we're dealing with. So we're gonna add a load temp fix address. That is like the worst, most undescriptive garbage name I've ever written, but whatever. So we set temp. So it should be this, right? We read from somewhere, right? And this could absolutely be wrong. And they denote that with a star. High byte. Yep. Yep. Read effective address, fix high byte of effective address. This Discord conversation I'm monitoring is funny. That's not the same one I showed earlier. I'm not laughing at them. They're both Gigabrain. In case they're watching this. I mean, the odds of that ever happening are like 0. If either of them find this video, I'll give you $100. No, I'm not gonna say that because then someone's gonna tell them. If you find it and you have some way to prove to me that you found it yourself and someone didn't show it to you, I'll give you $100. How's that? But it needs to be convincing. It needs to be convincing proof. You can't just say, oh yeah, no, I found it. That'll make it interesting. I'm gonna regret this, bro. I'm retarded. Where was I? We do this, it fixes the address. We don't retry, right? This will always happen. It always takes 6 clock cycles. Yeah, and then this happens. So we could think STX as an example, right? So that would come in here. All right, micro ops push, shoot. Right? Look at this. Where is it? Push ops. Right? So we could look at STX. It just does self.write. Uh-oh. Yeah, okay. Yeah. That's fine. So it'll put store A, and then that's the end of that. Or store X. I was looking at STX, I think. Doesn't matter. And then, yeah, I mean, I'm pretty convinced this will be, the read, modify, write will be the same. Because you have yada yada yada, this is all the same, and then this is the same as write. And then this is handled by the quote unquote ALU. Okay, I think this is a good commit. I'm glad I didn't refactor the pointer to be 8-bit, because it would have been a real pain in the rear to do the second addressing mode. I guess it wouldn't have been that bad, but it would have been slightly more annoying. So yeah, so for I'm not gonna double. Okay, I already double checked this. This is fine. I guess let me just make sure that this previous addressing mode isn't. So this should be impacted by the page boundary, right? Right. This is indirect, indexed indirect, indexed indirect. It uses this. Right. So fetch the high. Read from the address at X. Fetch from the high. Whoa. Yeah, I mean, okay, so it reads and then tosses the value. Right. We add X, we don't do the page crossing. Yeah, note the effector is always 0 page. Yeah. In that case, I think this is probably fine. Cool. User. Wow, that's all I changed, and it took that long. It's crazy. A lot of thinking, I guess. Want to make sure I'm doing things right. Again, I'm probably not going to do it on camera, because it's going to be like a really boring process of just checking everything with single step tests. I don't even know where I'm going to get these single step tests yet. I mean, obviously the internet, but I don't know like what set of single step tests I'm going to use, or if there even are any for the 6502. There probably are. I mean, knowing this community, there probably is, and it's probably extensive, and it's probably going to be very boring. Yeah, this looks good. Alright, whatever. And again, I don't want to spell this wrong. Where am I? Indirect addressing. Indirect indexed. Yeah. So, where does that put me? That puts me in regards to that stupid picture I had. Of course I closed the tab. Of course I have to look at this frickin' naked old guy again. Terrible. So this is good, this is good, yep, 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 yep. These are all solid. Yeah. So I guess I can look at some of these like more simplistic instructions. PHP, CLC, PLP, this junk. Right, again, this is just implied. Um, so I'm probably not even gonna make like an enum entry for addressing modes up here. There's just no reason to. Rather, I'll handle it one off in this decode logic. Probably. Maybe. I don't know yet. Right, where do I actually use this? I use it here. No. Yeah, I use it here. I don't know yet. Let's at least figure out what these do. PHP. What does that stand for? Push processor status. So probably 2 clock cycles. That would make sense. 3. Why 3? Okay. That is a question. So with accumulator or implied addressing, you do this. Yeah, that's a weird one. I mean, I guess. Oh, I mean, I guess that also works. PHP, PHA. I think there's also like a weird edge case. I mean, not edge case, but the 6502 in the NES is actually a variant. I think dubbed the 2A03, maybe 2A03. Don't quote me on that. That might be retarded. But I know it is a variant that doesn't have decimal mode. So I think when you push it, it actually doesn't push that flag properly. I could be totally wrong and just like remembering things like an idiot, but oh yeah, Ryko 2A03. I mean, this might also be me making junk up. Oh, I'm curious now. 2A03. Yeah, sound chip. Yeah, it was a combination of the stupid sound chip and the processor, right? 8-bit microprocessor. Dang, man. I'm not completely retarded. Yes, this is the sound chip and hang on, no, I might be retarded. No. Okay, no, I am thinking straight. That didn't work. Anyway, so I want to find push, or I guess the better place to check PHP. Yes, I was right. So that's a hex 30. Let's see, 1, 2, 3. 1, 2, 3. That's setting 2 bits. What 2 bits are those? NES CPU processor. I have a link in my actual source code. Status flags. Hey, see? Document your stuff. Document your stuff. So that sets. Oh, this is always set. I guess it makes sense. So both of these are pushed with this bit high. Hey, I was close. I said it only did it with 1 bit. It does it with 2. I was close. It's weird, like some of the details you remember about these systems. You forget crazy stuff and you remember even crazier stuff. Or maybe I'm just retarded, or both. Alright. So what's the move? Before I even think about doing this, I need to figure out how I'm gonna match, how I'm gonna like bring this into the match. I mean, I could just like do like match. That's a total hack though. I mean, I guess maybe a better way is we do oh man. Okay, so I guess the move might just be returning this. There we go. Yay. Oh, this was cool. I actually found this was a demo on RetroArch. The duck hurts you? That's stupid. You can't aim up either. It's kind of cringe. I suck. Anyway. You get the point. Yeah, I'll end it there, I guess. I am thinking about continuing work on this, because, like, RetroArch... Well, number one, I'm trying to get on the build list. The nightly build bot. That would be super cool. If that happens, I'm probably gonna go... It's like, I already have mobile ports. It's like, we have a build working for supposedly iOS, supposedly Android. I haven't personally tested either myself, but mean, it compiles. Um, so like that being said, I mean, you could also there's some crazy stuff you do like PS Vita, whatever. And it's like these things have accelerometers in them. So it's like there's rumble. There's so much like cool stuff you can do. It's like who knows what control weird niche controller support RetroArch could let you implement. So it's like I see potential there for really doing a lot with this emulator. Yeah. I'm tired. I am probably gonna keep working on it and just not live.